Someone had asked in class how to solve for n in the future value of a single sum equation if you weren't using the interest factor tables. And I wanted to create a video to explain it rather than spending time in class to do it because I don't think many people will be that interested. But it's a good thing to know. And not everybody has the same level of math knowledge, and this requires using natural logs. So, and you can certainly use the interest factor tables to do this. But this example will not show how to do it. Well, let's say your grandparents are remembering when a gallon of milk used to cost $3 and now it costs $20. You know inflation has been about 6% a year, and what you're kind of wondering is how long has it been since milk cost $3 a gallon? You can find the answer using the future value of a single sum equation, which is the present value of a single sum times 1 plus I to the power of time. I being the inflation, actually I being the interest rate, and inflation works as an interest rate. And then n is the number of time periods. So I plugged what we knew into the equation. The $20 is relative to the $3, a future value. The $3 relative to the $20 is the present value. Inflation of 6%, which I've converted to a decimal, is the interest rate. Add that to 1 to get the 1.06. And what we don't know in this equation is time, or n. So what I'm going to do is solve for the exponent of n. To do that, the first thing I'm going to do is divide both sides of the equation by this 3 to get it on a side by itself. So 20 divided by 3 equals 1.06 to the power of n. Oops, not m. And then 20 divided by 3 is 6.6667. And now we've got 1.06 to the n. To solve for n, I am going to use natural logs. So what I would do is go the natural log of 6. Well, Word is automatically capitalizing that L. 6.6667 equals the natural log of 1.06. Oops, n times the natural log. And I'll put that in brackets. So if I calculate the natural log of 6.67 and the natural log of 1.06 and substitute them in this equation, and then I can solve for n. And just to have a, wow, I don't know what that is, just to have a logarithmic calculator on the screen. Well, I'm trying to get this. Oh, come on. Here we go. So I need the natural log of 1.06. I think I have to do it this way. So that gives me 0.05826, etc. So I'll jot that down in a minute. And then I also need the, I've never actually used this internet calculator before, so I don't know how to clear it, but I'm just going to assume that if I type a new thing over, it'll work. And then the natural log of 6.67. I should carry that out a little more and make it 6.6667, but I'm not going to. And so there is the natural log of 6.67. So I'm going to take both of those numbers and pop them into my equation over here. So the natural log, I'm just going to copy this down. The natural log of 1.06 was 0.05827. The natural log of 6.67 was 1.897. I'm rounding a bit. Now I need to solve for n. So I'm going to divide both sides by 0.05827. So that gives me 1.897 divided by 0.05827 equals n. And then the final answer is 32.558 is my n.